All right, moving on to our next set of notes for target B. All right, we practiced some how to find the table and how to graph exponential functions. Okay, and when I told you at the end of our notes from the first day, which was yesterday, I told you that make sure you look at the number inside the parentheses, the number next to the exponent. That number is going to tell you a lot of information about the graph. If a number is a whole number, remember that graph is going up. Okay, so the first thing that you want to do for this question, especially question 1 and 2, is to look at the number. So look at the number next to your exponent. Obviously, we know that our exponent is going to be x, okay, in this case. The number represents a lot, right? Whole number, graph is going up. Fraction, graph is going down, okay? Just by looking at that, I can already identify, well, which one is going to be my answer. Okay, look at number 1. I'm not even doing anything yet, okay, to check anything. And then question 1a, as you can see, it's a straight line. Remember I told you exponential functions never be, they're never going to be a straight line. There was going to be a curved line. So I know option A is out. Next, 1b and 1c. Well, let's look at the number. Next to my exponent, I have the number 6. 6 is a whole number, so my graph should go up. And remember, every time you read the graphs, you start from the left side to the right side. So if I look from the left side to the right side for B, I know that it's going down. It's going down. But if I look at option C, it's going up. So again, option B should not be my answer. And again, I can check my answer, okay, because the next step that you should be doing for checking the answer for these is to plug in 0 for x to find the y-intercept, which should be the next number. So for example, question 1, your y-intercept should be 2. Why? Okay, let's check this out if it's true. Remember when I plug in a 0 for an exponent, so 6 to the exponent of 0 will always be 1. So that's saying 2 times 1, which is 2. Okay, when x equals 0, your y equals 2. So as you can see, it does cross through the y of 2. So yes, option C is my answer. Okay. Okay, so that's those two steps that you always want to be looking at. For example, question number 2. Okay, which of the graphs below represents the graph of the function? Okay, look at my steps. Look at the number next to your exponent. If it's the whole number is going up, if it's a fraction, your graph has to go down. Okay, and then plug in 0 for x and find the y-intercept. Which one of those graphs actually has the y-intercept that has to be crossing? So I'll give you a moment here, okay? Make sure you look at the graph. You stop the video if you need to. You're going to answer the question in the next few seconds. All right, you should obviously cross out C out because of a straight line. As you notice, option A and B are both going down because of a fraction. It had to go down. So yes, option A and B is correct. Now we need to figure out the y-intercept. Well, I need to plug in 0 for x. So when I plug in 0, this becomes 3 times 1, which is 3. Which of these graphs is crossing to the y-intercept of 3? Well, that is option A. So you should have picked option A. All right, moving on. It says, which of the following order pairs is on the graph of f of x equals 6 times 4 to the power of x? All right, well here, remember we need to plug in the values for x. It's like the table that we did yesterday. They gave us the values of x and they gave us the values of y. And that means that if I plug in the values of x, I should get the numbers that gave me for y. So for instance, if I plug x equals 0, my answer for y has to be 0 or 24. Okay, where am I getting this? Right here. I had option A and C with x of 0, but the y's could be 0 and 24. Let's try that out. Let's see. 6 times 4 to the power of 0. I know 4 to the power of 0 is going to be 1, so it's 6 times 1. That gives me 6. So actually, both of those options are wrong. So A is not part of it, C is not part of it. Next, look, I have x equals 2, okay? But I also have another option where x equals 2. My answers could be y equals 48 or 96. Let's try it, okay? So I'm going to try it over here. 6 to the times 4 to the power of 2, okay? Again, the power means that you're going to multiply the base, so 4, by itself 2 times. So 4 times 4, that's what it means. 4 times 4 is 16. So I'm going to have 16 times 6. And that's going to give me 96. So my answer for this is option D. I did not have to try option E anymore. Option D is my final answer. All right. Moving on to question number 12. So question number 3 is just plugging in values. We already know how to do this. We did the last semester, okay, for 2 of our units, okay. So it's just plugging in the values, making sure that the function is true, okay. And then lastly, we need to write an exponential function that can model the data in the table below. So they gave us a table, and we have to write the function, the exponential function for this. The way we write an exponential function is y equals a times b to the power of x. A represents your initial, okay? So your initial point where x equals 0, right? That's how we find our initial point, is like our y-intercept. And then b is your change. Okay, but remember, since we're talking about exponential, we're talking about change by multiplication. Okay, so here we go. Again, the change, how do you find the change? Through the y, right? 1 times y gives me 3. Well, 1 times 3 gives me 3. That means that if this is true, I have to multiply 3 all the time. So 3 times 3 gives me 9. Good job. 9 times 3 gives me 27. So far, so good. 27 times 3 gives me 81. So far, so good. That means that my b, which is a change, is going to be, okay, is going to be 3 to the power of x, and I'm just missing my a. What would my a be? All right, remember, is your initial point. How do you find the initial point? When x equals 0. So if I multiply going forward by 3, remember, I could always figure it out when x equals 0, even if they didn't give it to us. I just have to go backwards, right? Instead of multiplying, I'm going to have to divide by 3 in order for me to find my initial point, which would be my a. Okay, well, 1 divided by 3 is going to give me a decimal. That is just 1/3. So the exponential function for this one is y equals 1/3 times 3 to the power of x. Again, we practiced before. Okay, so try the next problems on your own.